And so today we will solve this problem, and we will use brute force approach in this video, and we'll tell you how to approach by the other approaches. Okay, so you will understand and that will work fine. So there is no magic formula, guys, no guessing, just a clean code we are going to use for this problem. So what you have given, just think that we have given an array. It's a integer array, you can say, and it consists of some prime numbers as a element, right? So for each index, let's suppose call I, right? You must find the smallest integer, and that will go to the answer at I. Okay, so answer at I is, let me show you how. So as you can see, we have given this array, we have given, right? And how we will find the indexes, right? So you know that if this is an array, right, let's write like this. So we have 2, 3, 5 and 7, right, guys? And indexes, you know, the I is index if this is 0, 1, 2 and 3. So if this is a nums that we have given, right, if this is a nums, so nums at I, there will be some element, right? And that element will go answer at I. Okay, and answer at I will also, we have the same size, right, as we have, and we have to find that, and it will go to the answer at I. It will store here. Okay, so for each index I here, right, you must find the smallest integer, that is called answer at I. And answer at I, what it will store, right? How will you going to find? So answer at I will go answer at I, or what you need to do, you need to do answer at I plus 1, right? Whatever the element will come, that will be nothing but it should be equal to nums at I. Okay, so if there is no such elements are there, in no such values are existing, you just need to return -1. Otherwise keep doing these things, and for each index it should be independent. Okay, now you can pause this video and you can understand what the question really says that, and it will definitely help you. Okay, so very first it is saying that you have given nums, it consists of n prime numbers. So this array is consist of n prime numbers, and you need to construct an array that is called answer length, such that each index I, the bitwise OR of answer and answer at I is equal to nums. So in basically you can say this part. So answer at I or answer at I plus 1 is nothing but equal to nums at I. So additionally, you must minimize each value of answer at I in the resulting array. What is a resulting array? This is a resulting array, or you can say this is nothing but answer at I. So at each value there is some element, not answer at I, it is answer array, you can say, but each element consists of answer. Okay, so this is what we have given, guys. If it is not possible, you know that what you need to do, you have to set the value as -1. So wherever you see in the -1, it means there is no condition satisfied this condition. Okay, otherwise it's give some value and it's stored at these indexes. I hope till now you understand. Okay, so what did I say to you? If you summarize this problem, it means for your given array, right, it consists of prime numbers, and for each index, right, you must have to find the smallest integer, right? If the smallest integer is there, you have to store at the answer at I. How? Only if the condition satisfy this one, answer at I or answer at I plus 1, it should be equal to the value of the array or element. If there is no such elements, you have to set the value as -1 for that index only. Okay, so as you can see here, the very first index at 0 is having set -1, and for other indexes it is independent. Okay, so this is what, guys, we need to do. So the constraint that we have given is, let me show you how. So if you come down, you will see the constraint we have given nums dot length should be greater than or equal to what, 1, and should be less than or equal to 100, and nums at I, it should be less than or equal to 1000. That means we don't need a fancy optimization, guys. We can simply try all possible values and we'll stop when we find the valid one. And since we check the value in the increasing order, the first match is guaranteed to be minimum, right? So what is the intuition here, right? Intuition very simple, guys. We have to try each element that we have given. As you can see, we have given these nums at I, so all the elements we have to try, each number we have to try. How we'll try all the value of j from 1 to nums minus 1, right? And we check that condition that we have given nums answer at I, or answer at I plus 1, like that we will check, and it should be equal to the nums. So as soon as we find the value of j, we'll stop, and if we never find 1, we'll say answer at my answer is that one. Okay, let me tell you how. So this is what we have given. Let's suppose the nums at I we have given, right? So for each nums at I, what you need to do, we should try all. Let's suppose there is two things we will take. J, that will go from 1 to this nums at I minus 1. Okay, then we should check j or j plus 1 should be equal to nums at I. So as soon as we find the valid j, right, we will stop there. If we never find j, we'll set minus 1 as a value. So that's what we should do, guys. Okay, it means what we are trying to do here, guys. We are thinking that means as an intuition we should understand what is the intuition. So think about the intuition. The very first what we should understand is here. Now give me 1 second. Okay, so very first for the intuition, guys, what we need to do, since the input is small, right, we have given the input and we have seen that the nums at I should be less than or equal to 1000. It's not a big number, right? So means it's a small number and we can find the prime number, right? So we can solve the problem by directly simulating the condition that we have given. What we have given for each prime number, let's call nums at I, there will be some prime number, right? So we should try all the possible values of nums at I starting from 1 to 999, we can say like that. Means 1 to nums at I minus 1 if it is less than or equal to thousands, right? For each candidate j, we should check j or j plus 1 should be equal to nums at I. So the first value of j satisfy this condition to be chosen, because the problem requires a minimum possible value. If no such value exists, we set answer equal to minus 1 as we have given here, right? Let me show you. As we have given here, right, that we will set. So this approach will work since each index is independent and the condition are small enough to allow the brute force, and we'll check the breaking values. Okay, so let me show you how. See, now you can see that, right? Very first what we have given is answer mean bitwise operation. We have given its return type is array, right? It means we need the all those values, right, that satisfy the conditions, right? Then we have the list of integers and it should be a resulting array, you can say that, right? So answer at I will be the value, right? So let's take that result is our answer, right? Or answer you can take where equal to new, and you will take the same size. For I will try, let me show you how. So we have given these nums, right, and we know that nums at the elements are some prime number, right? So we will take the same size, means the given array size, this is array and this is a same resulting elements are there, right? So very first we'll take the element from the array from here and we'll check this is a original element. Now basically we'll say okay, this is original element, and by default we have to set the candidate is -1 if it is not available, right? Then we should try all the possible j from 1 to original -1, right? So what is original? Nums at I -1, we can say that, right? This is the original one. So we'll so what we will need to do, we'll say okay, sorry, nums at this one, the original one. So we'll set the value here, and so we'll try from j equal to 1 to original, means 1 to, let's suppose if it is 1000, right? We know that, right? If it is 1000, we'll go to triple till 999, remember? So yeah, it was correct, -1 only. Okay, so for now we can take that it should be less than equal to or either thousands, it doesn't matter mostly, but you can try all the elements, right? So you will say okay, that is j and j plus 1. So let's check with if the condition is satisfied or not, means j or, right? You have to take j plus 1 if it is equal to nums at I, which is original. So you will check the value. If it is satisfied, the condition will get satisfied, and you will set the value. Otherwise condition, you will set the -1 that is already in the candidate, right? So if this is the thing, you will update your candidate from -1 to the j, and you will break it. So resulting elements will be, when the loop come from here to here, you will not continue the for loop, but we have to come from the for loop out, and you will set the candidate value. Like this you will update, and your resulting element will be set, and finally you will return as this value. In case if you have any doubt, guys, you can ping me in the comment box and we can understand from there. Okay, so let's check, let's do the dry run. How will you do the dry run? Let's think that we have given nums, and these nums contains array of element. Okay, let's say 2, 3, 5 and 7 that we have seen, that we will take. So at 0, what is the element is there? The element is 2, right? So when we are going to try, let's suppose for the j, it means we'll say okay, means we are talking about this line, right? So we'll say okay, so 1 will take with 2, right? Because we are taking j from 1, so j is nothing but this 1 and 2 is the value. So we'll say okay, is equal to, if this element is equal to what? 3, just for understanding, for when nums at I equal to 2. So if it's equal to 3, so there is no such matches there, guys, right? So we'll say set the value as a -1. So here we will set in the resulting element as a -1. Now so this we have checked when I equal to 0, right? And we have seen the value. When we'll say okay, I is equal to 1, now the element is nums at I equal to 3, right? Now we'll say 1 mod 2 is not mod, sorry, or is equal to, is 3? Yes, this is 3. So this time we have not seen this one, but this time we said yeah, fine. So we'll store this value as a what, 3. So not 3, sorry, is equal to 1, because this one is satisfied, right? Like that we will keep checking further. Again we will check the next value. Let me clean it here, or let me try it here. Okay, then we'll take I equal to not 1 1 2 2 2 2, will 2. What is the element is here? 5. So we'll say okay, 5. So this is the element we have. We'll say 4 and or 5, right? So we'll say okay, now is it satisfy equal to 5? Yeah, it is equal to satisfying. It means there is one value that will also set. What is the value is here now? So we'll say okay, we have set -1, 1, and then we are setting the value is 4. Understand why? Because answer at 2 will go 4, because this 4 satisfy with this value, means I will start from 1 to the original -1. Remember that 1 to original, right? That is why we have to check the j, all the combinations, guys, right? Then we'll come to the I equal to 3 where the value is 7 we have given, right? So we'll say okay, is the element 3 mod 4, not mod 4, or sorry, it's our operations. So we'll say is equal to 7. Yes, it is equal to 7. So now set the value 3. So the resulting element become what? As simple as this is become array. Very first we have seen -1, then 1, then we have is 4, right? So we'll say okay 4, and then we'll say is 3. So this will become our -1, 1, 4 and 3 are the resulting array, guys. Okay, so that's all I have in this video, guys. So I'll request you to write the time complexity and space complexity. I'll give the hint so you can write. Okay, how many elements we have here? We know that there is n elements. Let's suppose n is the size of the element we are taking here, right? And we are traversing to the nums at I, right? So okay, how many combination will become? Nums at I. So if this combination you are trying, so this combination is safe, first of all. So you can understand here, because we have nums at I we have, which is less than equal to 1000, correct? Let's check with the, this will go to the time complexity. Okay, then we'll think about how many elements we have to save here. Here we'll take okay O of n1 elements. So this will go for the resulting array. So this is your space complexity, guys, and this is your time complexity. Just you take like this. Okay, so if you able to analyze the values through the loop, you will find you will notice that there are some odd numbers. There is exactly one small valid value, and the brute force approach always finds its first. This means the solution can be optimized. So the brute force approach is perfect acceptable in this possible ways. So this is the question, guys, and this is the solution. In case you are struggling with the bitwise operations, let me know in the comment section. I'll create another video and I'll explain through the bitwise operations. So this I'm going to put it here, and please write in the comment section. Thank you.